Hello, everyone, and welcome to this Microsoft Learn Studio session, building your first Blazor WebAssembly app with Visual Studio Code. My name is Daniel Roth, and I'm a program manager on the ASP.NET team. In this session, we're going to learn all about Blazor WebAssembly, how to set up your machine, and how to build your first WebAssembly-based web application. Here's the agenda for this session. We're going to do some quick welcome and introductions, and then we're going to jump right into the Microsoft Learn module, where we're going to build our Blazor WebAssembly app using Visual Studio Code. Hopefully you've already started setting up your machine with the prereqs, and then we're going to jump over to aka.ms/learn/Blazor for the actual session content. At the end, we'll have time for questions, but we'll also have time for questions throughout the entire session, so feel free to post your questions into the chat. We have an all-star set of moderators on this call to help out with all those questions, full with knowledge and wisdom. We have Adrian Stevens on the call. He is a software developer, instructor, and program manager for Microsoft, who works with a talented group of folks and content authors to build free technical Azure training for Microsoft Learn. He's our Microsoft Learn expert on the call. John Galloway is also here. He's a PM on the .NET team, working specifically with folks on Mac. He also spends a lot of time with .NET open source. He's a former executive director for the .NET Foundation, and also spends his time promoting community projects and blog posts through the .NET Community Stand-Up at live.net. If you haven't been watching that, you should definitely check it out. And lastly, we've got Safia Abdallah. Safia is a software engineer on the Blazor team, so she'll be keeping me honest. She's also a longtime open source contributor and maintainer in the web and interactive computing spaces. A couple of housekeeping things. This session will be recorded. If you have any questions, again, please just use the chat window to post those questions. Our moderators will be there to help you. They'll be pushing questions also to me as needed to answer them and for the whole group. We also do have a code of conduct. There it is. Basically, just be open and respectful to everyone at this event. And you know what? Everyone in real life, because it's just a good way to live. And with that, I think we're ready to get started. Let's go ahead and head over to the Learn module. Go ahead and open your browser to aka.ms/learn/Blazor. I'm going to go ahead and do that myself. All right, and so that should take you to this page. Again, the link is aka, let me type it here for you, .ms/learn/Blazor, and that will bring you to the Microsoft Learn page for the specific module that we're going to be going through. Now, this is going to be interactive, hands-on, so get your machine ready, get ready to try out some bits, write some code. We want you to follow along, and as you have any questions, feel free to post them. All right, now down below, these are all the 8 units that we're going to be going through. We'll just be clicking through these. I encourage you to follow along as I go through them. All right, so for the introduction, we're going to be talking all about Blazor. Now, here are the learning objectives for this session. We're going to be configuring your local environment for Blazor development, and we're going to be using Visual Studio Code. If you prefer to use Visual Studio, or if you're on a Mac and you want to use Visual Studio for Mac, that's fine as well. Feel free to do so, no problem at all. We're going to create a Blazor WebAssembly project. We're going to add a page to it and then add some client-side logic to our Blazor WebAssembly app using just .NET and C#. No JavaScript coding required. This is a very basic Learn module. You don't need to really have any experience at all with Blazor. You just need some, very basic knowledge of web concepts like HTML. You don't really need any CSS either. Basic HTML concepts should be fine. Also, we expect that you have at least a little bit of knowledge of .NET and C#. If you're not really familiar with C# and you're completely new to .NET, there are also other Learn sessions, studio sessions that are happening during build that you should definitely check out, where you can get that intro to C# coding. All right, let's go ahead and click continue. So what is Blazor? Now, this page has a bunch of text, and you're welcome to go ahead and read through that. I've got a couple of slides here, though, that I'm going to use to help explain what this Blazor thing is all about. So suppose you want to build a sophisticated web application. It's going to have a rich, interactive UI. You want it to run on desktop browsers as well as mobile browsers. Maybe you want it to be installable as a progressive web app. It's going to have that rich interactive UI, so you're going to need things like, grids and dialogues, wizards, forms and validation. You also need to worry about authentication, localization, and so on. There's a lot going on with modern web apps. Now, historically, the only way to build such a web app would be to build it using a JavaScript framework. Writing the app in JavaScript or a language that compiles the JavaScript. And that's fine. I mean, there's wonderful frameworks in the JavaScript community, Angular, React, Vue, or whatever the latest hot JavaScript framework is. But on the back end, you then have a choice of what you want to use for your back end logic. You could use .NET, you could use Java, PHP, Python, Go, whatever you like. There's a whole plethora of choices that you could use for your backend server. But when you have two different platforms being used, one on the front end, one on the back end, that creates cost. You have two different languages, two different sets of frameworks, two different build tooling, tooling for editors that you need to use. That just creates friction. And it's kind of like, in a lot of ways, I think, learning another language. Like if you're having to learn another human spoken language, like I speak English, but have had to learn other languages in the past, like Spanish or Portuguese. And I can say hello and where's the bathroom pretty well, but to get really fluent in those languages, that takes time and that takes effort. And I think it's the same thing with development platforms and frameworks and languages. There's a cost for each additional one that you have to add into the mix. Well, historically, this was the only way to do things, but fortunately, recently, thanks to modern open web standards, this is actually no longer the case. There's another option. So Blazor is a web UI framework for building single-page apps using just .NET and JavaScript. It enables you to build your entire application using just .NET. You get the productivity of C#, Visual Studio, a consistent ecosystem, and stable ecosystem to build not only your modern web UI, but also your high-performance .NET backend. Blazor works in all modern web browsers, and it's also cross-platform and open source. Now, how does that work? Like, how is that possible? Well, there are two ways that Blazor apps can function. The first way we call Blazor Server. So a Blazor Server app runs your UI components on the server, using .NET Core, but it sets up a real-time WebSocket connection with the browser, and it uses that connection to handle all of the UI interactions. All the UI events get pumped to the server figures out how to update the UI and sends that back down to the browser in real time over that WebSocket connection. Blazor Server actually shipped last year with .NET Core 3.1 LTS, so it's been available for a while. The second mode or hosting model for Blazor applications we call Blazor WebAssembly. Blazor WebAssembly apps run directly in the browser. They enable you to run .NET code in the browser using a WebAssembly-based .NET runtime that you can deploy with your app and download with your app. At that point, you're just running normal .NET assemblies, normal DLLs, in the browser using that runtime. You just download .NET assemblies with your application and execute them like you would on any .NET runtime. Just in this case, it happens to be one that's implemented to run in a browser. Now, if you haven't heard of WebAssembly before, WebAssembly is it's an open web standard. Let's go ahead and go to webassembly.org, which is a page I think it's on the W3C site, or at least it's their landing page. WebAssembly is an open standard. It's a low-level bytecode for the web. Now, you don't typically write code in WebAssembly. It's too low level for that. But what you do is compile code to WebAssembly. It's intended to be a compilation target. So as long as you can take your code and compile it to WebAssembly, that code can now run in any modern browser on any platform at near native speeds. So that's pretty cool. And originally, WebAssembly was targeted at fairly low-level programming languages like C, C++, Rust, and so forth, where you can compile that code to WebAssembly and now run it in a browser. And so what we did is we took .NET and we built a runtime in WebAssembly that you can now download with your app. So that's how Blazor WebAssembly works. It works using this new bytecode for the web. It used to be that browsers could only speak JavaScript, but now browsers can speak both JavaScript and WebAssembly. And as a result, a whole variety of different languages. The door is now open to code in pretty much whatever you want in the browser, including .NET and C#. And what we're really excited to announce here at Build is that Blazor WebAssembly is now shipped, officially shipped, supported, and ready for production use. When combined with .NET Core, Blazor WebAssembly enables that full stack development experience with .NET. You can run your code natively in the browser. It's available with the latest version of the .NET Core SDK, version 3.1.300. It's also available in the box with Visual Studio 2019 16.6, as well as Visual Studio for Mac version 8.6. So the bits we're going to be using today, these are shipped and production-ready bits for building your next rich interactive web application. All right, so now to get started with Blazor, what you typically do is you go to blazor.net, that's the Blazor homepage, you install the .NET Core SDK, and then you can build using whatever tool you'd like, Visual Studio for Mac, or Visual Studio Code with the C# extension, which is what we're going to be using today. If you prefer a different editor, that's fine too. You can code in Vim or Emacs. The whole SDK is, of course, cross-platform, and you can pick the editor of your choice. But these three have great Blazor support. OK, so let's go back now to the Learn module. So we've gone through this. We've described what Blazor is about and what is WebAssembly, what specifically is Blazor WebAssembly. We are supported in all of the modern web browsers. And to get your machine set up, you're going to need that latest .NET Core SDK, as well as tooling so that you can get really productive building your Blazor WebAssembly app. And that's what we're going to do next. But before I jump into that, any questions about what Blazor is or what Blazor WebAssembly is? I'm just going to take a peek. See if we have any questions on the call from our moderators. All right, so we've got the code and conduct in there, the link to the Learn module. No questions so far. If you do have any questions, please, by all means, go ahead and put them in the chat. All right, and send them my way. If anyone has some of the moderators maybe just handle your questions privately. Some of them may get published to the site. I do see a question from Dijon or Dehan. I apologize if I'm mispronouncing your name. Could you please give an assessment of how good Blazor WebAssembly is to build large-scale web client apps, which ideally should be modular? Could it have modules load in runtime? Since Microsoft uses React themselves on all of their web apps, what are WASM limitations in terms of server resources, given that it has to do SignalR communication with it compared to using React from Microsoft, like Microsoft is using with Office 365. Sure, so Blazor WebAssembly is great for large applications. It turns out that .NET code, when it's compiled into assemblies, the .NET IL is actually a pretty compact format. There is an overhead for Blazor WebAssembly apps in terms of the download size to bring in the runtime. See, there's a chunk of the payload that's just the WASM file, the WebAssembly file that's needed to run the .NET code. And then you also need like the core framework libraries like System DLL and System Core DLL, those types of things. So there's a little bit of overhead to bring in that core capability. But then your app itself, the DLL that makes up your application, is usually pretty small. You'd have to actually write a lot of code before that the app code becomes significant. Now, apps can get, of course, very, very large. And one feature that we often get asked about is like, is there a way to like chunk up my Blazor WebAssembly app into different like lazy loaded pieces so that I can like load part of it and then load other parts? We call that lazy loading of app areas. That's not something that's directly supported by this initial release of Blazor WebAssembly, but it's on our backlog to address in the next release, which is coming with .NET 5. And I can talk a little bit more about that later. Now, for module-based development, there are also community projects out there for building modularized Blazor WebAssembly apps or Blazor apps in general. Octane is one that I know I'm familiar with. I'm familiar with the author. Sean Walker does a lot of work on that. So check out that. I think it's OQTANE.org with a Q, Octane. He's implemented a modular form of Blazor application. So you can do that today with the existing infrastructure. It's just not like a turnkey solution right now. Now, please note that Blazor WebAssembly apps do not use, let me go back to this slide so that everyone's clear on this. The WebAssembly app runs purely client-side. It doesn't need a SignalR connection at all. In fact, it can be published as a static site. The app itself is just a bunch of static files that you can publish on any static site hosting solution and then download them into the browser. And at that point, you don't need .NET on the server at all. It could be nothing on the server. It could be, Python on the server, a fast typing monkey. It doesn't really matter because the app is purely client side, just like with a front-end JavaScript based application. It runs the same way. It's only if you decide to host your components using the Blazor server model that you need that persistent real-time connection with the server so that the UI can function. So those are two different hosting models. They operate in different ways. Okay. Right. Thank you for the question. That was a great question. And yeah, thank you for the link to Octane. A couple more questions. Are there specific scenarios where each one works best? Okay, back to the hosting models. Let's describe what are the trade-offs between these hosting models. It's a great question. So Blazor Server is really simple to implement because your code is already running on the server. So when you need to do things like talk to a database or access data that's only available server side, well, you're already there. So your components can actually just go ahead and open use any entity framework core to talk to the database, get your data, and do whatever you want. The app also loads really fast because very little needs to be downloaded to the browser. We download a little bit of infrastructure code to set up the WebSocket connection, and all of your app code just stays on the server, so that you don't need to download all that. The app loads very quickly as a result. Now, it is a stateful server model, though. So every client that then comes to a Blazor server app, they're going to need that persistent connection. So you need to handle connection scale out. And there's going to be state being held on the server for each of those clients. So you have to plan for the scale out characteristics of a Blazor server app. For connection scale out, we actually provide a service to help you do that. The Azure SignalR service is specifically built for handling massive connection-based scale out. So those are the benefits of a Blazor server app. Blazor WebAssembly is a little different. You're offloading all of the UI to the user's device, to the client. So the scale out characteristics on the server are totally different. You can just use like a static site hosting solution, and that's all you need really for the client side part of your application. It can function completely offline because all the files are on the user's device. So you can build like progressive web apps where all those files get cached locally and they work even when there's no network connection at all. So that's pretty cool. The initial download size, though, is larger. Like you're having to pull in the runtime down and those core framework libraries. So they can be a little slower to load up. But of course, once they're loaded, all those files get cached and then you're good to go. So the next time the user goes to that app, it can load up much faster. Great question. Thank you, moderators, for posting links. There's great stuff in the docs that explains these differences. Okay. Did we say this has access to the NuGet library? Yes, so these are just .NET apps. So you can use any library on NuGet.org that supports .NET Standard. Blazor WebAssembly supports .NET Standard libraries. And the last one, is there a hybrid Blazor server and Blazor WebAssembly model where you kind of like try to use both? Currently, no, not really. Right now, you basically pick one hosting model versus the other. We've had people ask this question before, like, is there a way I could maybe start out as a Blazor server app and then switch it to be a Blazor WebAssembly app at runtime? Technically, those things are possible. We don't have out-of-the-box support for those things. It'd be really interesting to see, though, people in the community and the open source ecosystem playing around with the Blazor bits and see what you come up with. All right, let's move on. Okay, thank you for your questions. Great questions. Okay, let's get our dev machine set up. We want to build our first Blazor WebAssembly app. Okay, what do we need to do? So first, you're going to want to get Visual Studio Code if you don't already have it. So go to code.visualstudio.com. download Visual Studio Code if it's not already on your machine. It's a super lightweight install, but wow, what a powerful editor for such a small payload. Like, it can do so much. It's great for not only .NET development, but developing in a whole bunch of other platforms like Python and JavaScript and so forth. So go ahead and download and install that. Okay, the next thing you're going to want to do is you're going to need to install the latest .NET Core SDK, and you can get that by following the link here in the Learn module. This will bring you to the download page. Now, there's a lot of links on this page. The one you want, if you're on Windows, is this. You want the SDK, so SDK 31300, and then pick the right link for your platform of choice. Like if you're on Windows and x64, that's the right one right there, the x64 link. Mac, there's the PKG. Linux, there are docs on how to set up your machine with .NET Core on Linux. If you want a simpler way to do that, honestly, what I do is I go to .net, dot.net, and then I just click download, and then this SDK button is probably the one you want. This page will detect what OS you're on, and then surface an SDK link that's specific to your machine. And that should give you 31300 of the .NET Core SDK. So make sure you get that version. If you have an older version, that's not good enough. We just shipped Blazor WebAssembly with this latest version of the .NET Core SDK. So make sure you're getting 3.1.300 of the SDK. All right, perfect. Okay, once you've got the SDK set up, you have everything you need to build a Blazor WebAssembly app. Now, these instructions were written up a little bit ago when we hadn't yet, announced the official release of Blazor WebAssembly. So there's a step in here about installing templates using some command line instruction. You don't need to do that. Don't do that. That will get you like the release candidate build. You want the latest, greatest shipped bits, which we just shipped today. If you have the 31300 version of the SDK, you're good to go. Okay. Now let's go and make sure that Visual Studio Code is all set up correctly. We have a couple of extensions that we're going to want to install into Visual Studio Code for our Blazor development. Okay, we're first going to want to get the C# extension, if you don't already have that. That's going to get you the ability to run and build and debug .NET projects. It'll also give you the tooling for dealing with Razor files, which is this combination of HTML and C# that we use in ASP.NET Core for web app development, as well as in Blazor applications. Okay, so we're going to get that. And then we're going to need the JavaScript debugger extension so that we can also debug our Blazor WebAssembly apps if we want from within Visual Studio Code. Okay, so let's go ahead, and I think I can go ahead and shut down my PowerPoint sharing. There we go. And let's go find, let's go ahead and open up another Visual Studio Code instance. Have one up with my notes. All right, here's Visual Studio Code. Let's click on the Extensions tab. That's this one with all the little squares on the left-hand side. And then we can make this a little bit bigger so we can see the pretty icons. There we go. Okay, now we're going to search for C#. All right, and there's the C# extension. You can go ahead and click on that. I've already installed it. But if you haven't installed it, then it should have like a big green install button both here on the left-hand side and on this right pane. So go ahead and install the C# extension. That will get you the basic .NET development tooling for Visual Studio Code. Once you've got that, you should be good to go. Next, we're going to get the JavaScript debugger extension. And we're going to want this nightly one. This is the one from Microsoft with the latest, greatest, hottest JavaScript debugging functionality. Okay, again, you should see a green install button either on the right-hand side here or in the left-hand pane. Go ahead and install that. Once you've got the JavaScript debugger nightly extension installed, make sure it's this one. Go ahead and click on this little gear icon because there's one setting we want you to set to just make sure that you can do the full Blazor WebAssembly debugging. We're going to go down here to Extension Settings. And then scroll all the way to the bottom, And then there's this JavaScript Use Preview section right down here. You see this? This is the magic section. I want you to check this checkbox right there. Go ahead and check that, and that will enable the latest, greatest, awesomest JavaScript tooling in Visual Studio Code. All right, cool. If I can get out of this. Okay. that's all you need. So you now have all of the extensions installed that you need to do Blazor WebAssembly development. All right. So we've done that. Good. We checked that checkbox. Good. Got all the extensions. Looks like we're ready to create a new Blazor WebAssembly app. So we're going to open a terminal. Use whatever terminal you'd like. I'm going to use the one in Visual Studio Code. And then we're going to run this command, .NET new Blazor WASM-O CI calc. OK, so let me go into Visual Studio Code. I'm going to go terminal, new terminal. You could hit Control backtick in order to get to this terminal. And just make sure that you've got the right SDK version. To do that, just run .NET and type -- version. If this is the first, if you just install the .NET Core SDK, you'll probably get like a first run experience where it's like sort of setting itself up. That'll just take a second. But after that's all done, you should see this number. 31300 is the magic number for the correct .NET Core SDK that you want. OK? And then if we type .NET new, that's the command you use to create new projects using the .NET Core SDK. Let me make this a little bigger. If we scroll up here, and there it is. There's Blazor, well, we might as well show both of them. Blazor Server and Blazor WebAssembly. Remember we talked about those two hosting models. There's a project template for both of them. We're going to be using the latter, Blazor WASM or Blazor WebAssembly. WASM is short for WebAssembly. But if you want to try Blazor Server out, that's fine as well. You can try the other template. OK? All right. So now let's do, I'm going to do mine on the desktop. Let's see, make sure I don't got anything there. OK. So we're going to type .NET new Blazor WASM is the name of the template we want. And then I'm going to pass in that option -O. This is just the output directory where we want the project to go. If you don't specify this, it'll just create the project in the current directory. I don't really want all these files just sitting on my desktop, so I'm going to create a folder for them. And I'm going to, what is it? It's got a name they want us to use, right? CI calc. OK, great. So CI calc. And just hit enter. And that should create our Blazor WebAssembly application. All right, great. And then we can see the folder. I'm going to go ahead and move into that new folder that was created for my project. And there we can see all of the files, the stuff that makes up this project. We'll take a look at those files in just a second, but let's just go ahead and run it. Let's see what it does. Now, to run this application, all you have to do is type .NET run from the folder where the project is at. So I'm already in the CI calc folder. I'm going to hit .NET run. We'll just wait a second. .NET run will build the project, create the .NET assembly for this app, and then it will also start the project. It'll run it on my development machine, and I can tell it's now running when I see these log messages that say the app is now listening at localhost 5001. So this built my Blazor WebAssembly app, turned it into a bunch of files, and then it created a little developer server, like a little mini web server to host those files so that I can try them out during development. OK, so let's go to our browser and let's go to, what is it? Well, you can probably just click, control click right there. And there it says it's loading, and there's our app. You just built your first Blazor WebAssembly app. Pat yourself on the back. Good job. Well done. All right, let's take a look at what we got here. We've got some tabs. This is like a simple single page app style application. We have a home page with some static markup. We have a counter page with this counter that has a button. Then you click the button and the count goes up. Now, there's no page refresh happening here. We're not like doing a form post back to the server. This is all happening client side, updating the DOM. Historically, that would have required JavaScript. We didn't have to write any JavaScript to make this app happen. This was all done with .NET and C#. Pretty cool. There's also this fetch data page. This page is actually downloading from that little mini web server a static JSON file, simulating basically a web API call and deserializing that JSON data into this weather forecast table that you're seeing on the screen. Well, it deserializes that data into a .NET array of objects and then uses UI rendering logic to create this table on the screen. OK, so there's a web API call happening here behind the scenes. We can tab around. Like every time I tab around, this is all client-side routing. We're not going back to the server to go to each of these different URLs. Blazor is actually intercepting the browser navigation and then routing that navigation to the correct component and rendering that component. So this is all happening client side. We're not going back to the server as we tab around. Okay, now I said this is really running in the browser on this fancy WebAssembly runtime. Is that really the case? How can we see that? So there is a way to see that. I'm going to hit F12 in Edge. By the way, if you're not using the new Edge, you really should. Like, I strongly recommend it. If you don't have it, go to Microsoft.com/Edge and download and install the latest Edge. It is amazing. Like, it is gorgeous. It's beautiful. It does everything you want to do if you're a web developer. I love it. Go get the latest, greatest Edge. Highly recommend it. Okay, so in the browser, go ahead and hit F12, and you'll notice that in the console of the browser DevTools, it says that there is this debugging hotkey. Hit Shift-Alt-D if we want to debug this Blazor WebAssembly app in the browser. Okay, so let's give that a try. I'm going to hit Shift-Alt-D. Now, what this is going to do is a little bit magic. It's going to open up the browser DevTools. And it's showing me an error page. That's expected. We're going to look at that in a second. But this is opening up the browser DevTools and is going to try to remotely connect to the tab with our Blazor WebAssembly app and try to debug it. And when it does that, it's actually going to do it through a proxy. That's a .NET debugging proxy. The protocol for that endpoint is just the normal JavaScript debugging protocol. But using this proxy, we augment the protocol with .NET specific metadata and stuff so that you can debug your C# code in the browser. Okay. Now, in order for that all to work, we actually have to run the browser with remote debugging enabled, which I didn't do. This page is telling me how to do that. So there's instructions here for Chrome. There's instructions for Edge. I'm going to pick Edge because I love Edge. So I'm just going to copy this command. I'm going to hit Windows R on my Windows machine, and I'm just going to copy in that command and run it. And that's going to fire up a new browser, but this time with remote debugging enabled. Perfect. Okay, now this one should be ready to go. I can close the other ones. I'm not going to use those. Okay, so this browser instance has remote debugging enabled. I'm going to hit Shift-Alt-D again. It's going to bring up those browser DevTools, and this time it should connect, and it does. I'm going to take these DevTools and just snap them off to the side next to my app and give myself a little bit more space. All right, cool. And then let's go look in here, and we can see, there's the CSS stuff. This app's using Bootstrap. There's this framework directory with some JavaScript stuff in there to get the app bootstrapped, like get it started. Different Bootstrap. And then we can see this files node, and in here we see all of our code. Like here is program CS for our Blazor WebAssembly app. Just normal C#, normal program main function. That's starting up the Blazor WebAssembly app. We can also see the UI code for our Blazor WebAssembly app. These are the .razor files or Razor components that make up the UI for the application. So here's the code for this counter page. It's got some static HTML. It's got a button on it, and this button has an on-click handler. Normally, you would put like a JavaScript event handler here. But this isn't doing that. This is pointing to a chunk of C# code, a C# method that's in this component, this increment count method. When the button gets clicked, the increment count method then increments this current count field, and then the component re-renders. So let's set a breakpoint right there on our increment count method. I'm going to go ahead and click that. And there, we just hit a breakpoint in .NET code, C# code, running in the browser on a WebAssembly-based .NET runtime. We can even, like, if I collapse this, let's look at the locals. We can see the state of the current count, that it's currently 0. I'm going to hit F8 to continue, and then click it again, and we can see the current count is now 1, as you expected. So you get a in-browser debugging experience for your Blazor WebAssembly applications. This is really running fully client-side. Okay. And actually, I want to clear that breakpoint. It's going to clear that so it doesn't cause us problems later. Now, where is the WebAssembly code? If we look at the network tab, let's go ahead and refresh. Well, that's not very much. There's only like 33 kilobytes of Stuntland controller file. It's like really refresh. Now still, like now it's 219 kilobytes, but still, like where's this WebAssembly then? Well, when the app first runs, Blazor will aggressively cache the runtime and the framework libraries so that subsequent loads of the app are much faster. So all those files got downloaded and then cached. You can see them if you go poking around in the application tab. Go look under cache storage and look here. There's all the files. Here's all of our our downloaded assets. Let me see if I can get enough pixel space. Let me make this bigger. Let's make this all the way across. There we go. So like way down, you can see DLLs, and they all have the, they're hard to read because they've got these hashes at the end, but these are all DLLs that were downloaded with the app and then cached. And way, way, way at the bottom, there's this .NET.wasm file. That's the actual WebAssembly runtime for this application. There it is right there. And it all got pre-cached on the first load. Now it is a little, it looks a little big. It's quite a bit of stuff that gets downloaded here. Maybe you noticed in the console that, during development, we're seeing, over 6 megabytes of assets being downloaded into this app. Don't freak out about that. That's not what the app will look like when you publish it. When you publish your Blazor WebAssembly app, we run it through a .NET IL linker that strips out all of the unused .NET code. We also pre-compress those files with Brotli compression and really shrink them down. Default Blazor WebAssembly app published using the pre-compressed Brotli files weighs in at about 1.6 megabytes or so. So this is just during development. We turn off the pre-compression and the IL linker steps during development, just so that your build times are faster. Because the IL linker takes a few seconds to run. When you're trying to iterate on your UI, that can be a little annoying. So don't worry about this number. We'll see a published Blazor WebAssembly app hopefully a little bit later. Okay, great. I think we can close this now, and that looks good. All right, so we built and run our first Blazor application. Let's go back here. Now, if you want to shut down the server, you just hit Control-C. That'll stop the application, and then you can rerun it again by just running .NET Run. Okay, so that's how you do that. Let's go ahead now and take a look at the code a little bit. We saw some of it already, but let's go ahead and open our project. So I'm going to open a folder, and I'm just going to go to my CI Calc folder and open that up in Visual Studio Code. Cool. All right. So now we can see the files that are in our project. In a second, you may see a notification pop up here. Let's see if it may take a second while it thinks about it. While we're waiting, go ahead and take a look. There's that program CS file that we saw in the browser. This is just like you would see in there it is. So if you see this pop up, go ahead and click yes. Yes, I would like all of the stuff I need to run .NET projects and Blazor WebAssembly projects in Visual Studio Code. Click yes on that one. All right, so this is just like a normal program main class. It's got some stuff in it to start up the Blazor WebAssembly app. Here's our project file. Go ahead and take a look at that. This is the CS project file. This just defines all of the dependencies for this application. Notice that Blazor WebAssembly supports .NET Standard 2.1. So yeah, you can use .NET Standard libraries in your Blazor WebAssembly app. Here are all the packages that are used to create Blazor WebAssembly apps that we added as part of creating the project. We've also set you up with the new SystemNet HTTP JSON library. What's that? Oh, that's a nice new helper library with some extension methods to HTTP client that that let you send and receive JSON using the new System Text JSON serializer. So that just shipped this week as well. So we give you that right out of the box. Okay, and then we have these Razor files, like you can see up above. There's the pages directory. There's our counter component again. Each of these .razor files represents the UI of our app. They're implemented in this Razor syntax, which is a combination of normal standardized HTML as well as C#. Typically, you switch between the two using this @ symbol. So @ means I'd like to write some C# code now instead of HTML. But it's also pretty intelligent about knowing that you're writing HTML or C# at any given time. Each of these Razor files will get turned into a normal .NET class as part of building the project, and that's what makes up the UI of your application. All right, let's head back over to the Learn app. Okay, so we've run the application. We saw it running. Go ahead and click Continue. And we've already done a little bit of looking through the application. We saw the Blazor WebAssembly project file. That was the CS proj file. We looked at the program CS file. That's the entry point for the app. And then we've talked a little bit about what Razor is. That's how we're going to write the UI for our Razor components using that combination of HTML and C#. Okay, I'm going to just pause here real fast and see if anyone has any questions about any of that.
So Dan, Adrian here. A couple of great questions came up, actually a lot of them. A couple we haven't answered yet. So I think it was Tim here was asking about GUI tooling. And I see John's just about to respond as well. Are there any GUI tools for drag and drop UI development for Blazor today?
Not that we ship. We don't provide a like designer style GUI tool for Blazor. There are some third-party offerings out there, like Radzen is one I'm aware of. Radzen is like a low-code, fast app build, rapid application development environment for Blazor, where they do give you a full GUI experience for generating Blazor applications. So if you're looking for a GUI experience, you might try Radzen, but we don't provide one. Instead, what we focus on more is the like text editing, code editing experience for typing your Razor code.
And a couple other questions that came up. People are asking about referencing .NET assemblies and NuGet packages. And I want to make sure I answer this correctly. So we're looking for things that target .NET Standard 2.0, correct?
Or 2.1. We support .NET Standard 2.1. So every version of .NET Standard, as the version gets bigger, the API surface area that's standardized by that version gets a little larger. So .NET Standard 2.1 is the latest version of .NET Standard and has the largest surface area. Blazor supports .NET Standard 2.1. So any .NET Standard library that targets 2.1 or earlier will then work, because earlier versions of .NET Standard use less API, so therefore they should be fine. Now, the caveat to that is that the libraries will work within the constraints of the browser security sandbox. When we download your code into the browser and run it, it's running inside the same browser security sandbox that's used to run JavaScript code. So you can't do anything you want. Like you can't like arbitrarily mess with the user's file system or make arbitrary network connections or go mess around with the Windows registry, you know, those types of things. Basically, if you can't do it in JavaScript, you can't do it in Blazor WebAssembly either. If you can do it in JavaScript, you can also do it in Blazor WebAssembly, but no more. So that's the constraint. So some APIs that are available with .NET Standard, you can code against them, but when you try to use them in the browser, you'll probably get like a platform not supported exception if you try to like open a random socket off into who knows where, because that's not something that you can do within a browser. But otherwise, anything works. Like that example I showed of when we looked at the project file for the application we created, like system.net.htp.json, is a great example of this. Like that's just a .NET Standard library. It works in mobile apps, server apps, works anywhere you want to send an HTTP request that has some JSON data. And we just happen to use it in a Blazor WebAssembly app so that because it's just a normal .NET Standard library. Great question. All right. Anything else? I'm just scanning through here. Moderators, feel free to thanks Adrian for pointing that one out. If I've missed any others, feel free to let me know. So, okay, there was a question here by Pramod. I apologize if I'm mispronouncing your name. That said that earlier blog post suggested that there will be more types of Blazor hosting models. Can I comment? Yes, I can comment on that. So far we have two supported Blazor hosting models, Blazor Server and Blazor WebAssembly, which is what we're playing around with today. Now, we have been experimenting with other hosting models for Blazor UI components. Blazor components are actually really decoupled from how they get eventually rendered. Like a Blazor component will render into sort of this in-memory representation of the UI, and then something else can take care of actually applying the changes to the actual live DOM in the browser or whatever it is that's going to actually draw the pixels. So we've been playing around with using Blazor components in other ways. Like, for example, we did an experiment where we used Blazor to write Electron apps. If you're not familiar with Electron, Electron is basically a Chromium shell that's embedded into a desktop app so that you can write native desktop apps using typically JavaScript and web technologies. And they run cross-platform, Windows, Mac, Linux. In fact, Teams is a Electron app, I believe, as far as I understand it. And there are a bunch of other Electron apps out there. Visual Studio Code, I believe, is also an Electron app. We typically, though you write Electron apps with JavaScript, we've experimented with using .NET by using Blazor for the component model. Oh, there's also another experimental project called the Mobile Blazor Bindings project from our friends on the Xamarin team. Xamarin's the technology in .NET for building like native mobile applications. What they've done is they've experimented with taking Blazor's component model and instead of having it render HTML, have it render just native UI components from the underlying OS, like you would do in a Xamarin Forms application. So using the mobile Blazor bindings, you can build fully native mobile apps for iOS, Android that are using native UI, not web UI, but native UI, all using the same Blazor programming model that we're going to be playing around with today. Now, these are experiments. They're not. When we say experiment, it means that we don't know if they're ever going to ship or when they will ship. We are looking for feedback on them, and so if you find those scenarios compelling, like being able to use the Blazor programming model for more than just web apps, you'd like to be able to build native desktop apps or mobile applications, hybrid style applications, let us know by trying out those projects and giving us your feedback. Okay, let's move on. If there's no more questions, it's time for a test. Oh, okay, so we're going to check your knowledge. Check your knowledge and see if you've been paying attention to this to this Learn session. Okay, so there's 2 questions here in the Check Your Knowledge section. First question, I get to ask you questions now. Blazor WebAssembly apps are powered by which runtime? Option A, the runtime provided by the browser, presumably meaning like the JavaScript runtime. Option B, the .NET Mono runtime deployed with your web app. Or C, the JavaScript runtime deployed with your web app. Cue Jeopardy music here. Doo, doo, doo. The correct answer is B, the .NET Mono. Now it says Mono here. What's Mono? Like Mono is a cross-platform .NET runtime that we use for our mobile workloads, like Xamarin applications. But if you've been following along with .NET 5, you may have heard that the Mono runtime and the .NET Core runtime, like all that stuff is being unified under this one .NET vision so that we don't have so many .NETs and we just have one set of .NET runtime assets. So the runtime that we're using for Blazor WebAssembly apps is all part of that, is going to be part of that .NET 5 unified story. So the Mono part, not really as important, but it is a .NET runtime. It is running on top of the browser provided JavaScript runtime, but it's a layer on top implemented in WebAssembly. Okay, second question. How is Blazor WebAssembly UI defined? As Razor pages, as a mix of HTML and C#, as XAML pages using XML, or in C# alone defined in .NET standard libraries? Correct answer is A, using Razor syntax in these Razor components, like we saw with the counter component. Let's see if I got it right. Woohoo! Yes! Should be getting more experience points. Yes, I'm ready to level up. So make sure you're getting credit for all the work that you're doing. Okay, we're moving on to the next unit. Okay, so we're ready to start actually working on our application. Before I do this, actually, let's go ahead and do this. We're just looking at the time, making sure that we've got enough time to get through everything. Let's go ahead. We've already opened up the project in Visual Studio Code, and we clicked the Yes button, hopefully, to have the assets that we need there. All right, so now we are going to create a new Razor page in this app that's going to have like a compound interest calculator on it. Okay, so let's go back to our app, and in this Pages folder, we're going to right-click on the Pages folder and just add a new file. And I think they want it called compound interest.razor. Is that right? Did I get that right? Make sure I'm doing it right. Yep, compound interest.razor. Hopefully I spelled it correctly. All right, and then in compound interest.razor, currently it's just a blank file. It's got nothing in it. We want to add a little bit of markup. It says we want to add the @page directive at the top. So I'm going to copy this. Try to copy this. And I'm just going to add that at the top. Now, what does that do? What is this thing? @page? So this is, we're going to talk more about this in a second, but this is an example of a Razor directive. And this affects how the component gets compiled when you build the application. And what this is adding is it's adding a route for this component. We saw this in the counter component as well. Here, @page/counter. That's what enabled us to browse to /counter in order to see this app. Okay, so now while I'm while I'm modifying things, actually, I want to do something else. I'm going to get this app set up. So I'm going to open up my my terminal again. All right, so I'm going to go ahead and get this app running. So I'm going to do .NET run, and that should be fine. It should just build and run, just as it is, just with that one little file added. Okay, so now it's running, and I'm going to click on the link just so I have a browser tab open with that with the application. Control click. Okay, so there's our app. The other thing I'm going to do, this is kind of a fun trick. Like when you're building UI, right, you want to be able to make changes and see those changes as quickly as possible. You don't want to be like killing the server and restarting the server over and over and over again. Well, once the server is running, there's really no reason to restart it. All you actually need are the rebuilt assemblies, the rebuilt .NET libraries that make up this app. Okay, so all we really want is something that will like watch as you make file changes and this rebuild. And the server can stay running. All it's doing is serving up the files. So as the files change and you refresh the browser, you'll get the new files. But you don't need to tear down the server and restart it. So I'm going to leave this terminal. I'm going to click this plus button to create a new terminal. And then I'm going to run this this other .NET command, .NET watch. Watch will then watch all the files in this folder. And when they change, it will do something, whatever you ask it to do. And so what I want it to do is I want it to run a .NET build on my project. Okay, does that make sense? So now I've got a little file watcher that's just watching my files. And as they change, it'll rebuild them. The server's still running, serving up those files happily. And then we can just refresh the browser. So I can change my code, refresh the browser, and hopefully, if the watcher has built the app quickly enough, then I should see those changes. Okay, so now that's all set up. We can just hide this, and we don't ever have to think about it again. We should just be able to edit our code and refresh in the browser. It's a cool trick. All right, so now what do we want to do next? Let's go back to our exercise. We've added the page directive. We're going to add a little bit of HTML. Okay, so that's just normal standard HTML, nothing fancy going on there. Okay, and now we want this page to show up in that left-hand nav. Like you see these tabs over here? These are all pages. How does that work? Where is that coming from? Well, this is all being generated by the layout for this Blazor application. So if we go to the app and we look in this shared directory, you can see there is this component. It's a Razor file that is the layout for the app, and it's a special component because it inherits. This is like the base class for this component is this layout component base. And the only thing different about a component that derives from layout component base is that it has this special body property that you can use to say, I would like the body, the whatever component page I'm currently rendering, its content should be rendered right here. And then you can define a bunch of UI around that component. That's what this is doing. It's a layout. It's defining the layout for the app for all of our pages, okay? So what does this layout have? Well, it has a div for a sidebar, and it's got another component. So this is how you use components from other components. You use element syntax with the name of the component. How do you know what the name of your component is? Well, it'll be the name of the file. The name of the file will be used to generate the C# class for that component. And then you use that class name for the tag name for that component. So we've obviously got another nav menu component someplace. Looks like it's over here. We'll look at that in a second. And then we've got the main div for the app where we're rendering the body of the application. Okay, let's go look at nav menu now. Okay, well, nav menu's got a little bit more markup going on, but it's not too bad. Like at the top, there's just some HTML, which is implementing that hamburger button, right? The toggle button that allows when the tabs are collapsed, allows you to toggle them out. And then we've got a main div with just an unordered list, a bunch of list items. And each of these list items then uses another component. In this case, it's a navlink component. Now, a navlink component is a built-in component with Blazor. It's provided out of the box, and it's not that fancy. All it is an anchor tag. That's literally what it is. A navlink renders an anchor tag with one additional feature, which is if the browser's current address matches the href, like matches the link for that anchor tag, then it adds a class to that anchor tag to say that it's the active link so that you can style it differently. Like if you go look at the app, you can see that because I'm on the counter tab, this tab is styled differently. So that's how that's working. It's, we've got some custom CSS style that's looking for that active class that's being added by the navlink component. But you can just think of a navlink as an anchor tag. That's all it's rendering. All right, and we've got all three nav links for the three tabs that we already have on the app. And I believe all this is asking us to do is add a fourth one. So let's go ahead and copy this. Now there is one little, I believe, one little typo. Sorry about the typo. Let me go ahead and fix the formatting on this. So let's look at this nav link. So there's a list item with some classes, some styling. Navlink, the class is navlink, that looks fine. And then we got the href is set to calc. Now we actually want this link to point to our compound interest component, which we've set up with a route for compound interest, not with calc. So let's go ahead and fix that. I'm going to change this href to compound interest. Okay, so hopefully you're paying attention so that you don't miss that step. All right, and then we just have a span, which is setting up the friendly text, the text that we're going to display in that tab for this nav. Okay, and I shouldn't have to rebuild or start anything. Remember, we set up that .NET Watch that's just happily building away as I change things. So I should just be able to go here and refresh in the browser, and there's our compound interest tab. It just shows up. Okay, there. So now we've added a new page. All right, what's next? Let's go back to the steps. All right, so we've done this. We did it a more clever way. We didn't have to run .NET Run because we're using we've already kept the app running and just using .NET Watch to watch for file changes. Okay, now we're going to add a little bit more HTML to our compound interest page. We're going to add a table. So this is just a simple static HTML table, nothing fancy going on here. Let's go ahead and copy that and put that in our compound interest page. Okay, and then we should see the build kick off. You can see it started and it's running, and so our .NET Watch is doing its thing. That means we should just be able to go back to the browser, assuming the build completed before we hit refresh, which it didn't. Let me run it again. Then now we can see the table show up. Okay, all right, so now we've got that. That's just some markup. And then we want a button. Okay, and the button's not currently going to do anything because it's not, you notice it's not wired up to anything yet. But let's go ahead and add the button to the page. There it is. Again, .NET Watch kicking off, doing its thing. And we should just be able to refresh, assuming the build's completed. If you don't see it yet, just hit refresh again. Refresh maybe one more time. There's the button, and we can click on it all we want. It's a lovely button. Doesn't do anything yet. Okay, that's going to be the next step. We're going to add some logic to this component so it does something useful. All right, moving on. Any questions about that? Moderators, anything for I should pay attention? The more you guys can do to present solid, sufficient. Oh, it looks like John's already answered that question, so you guys can read that in the chat. Okay, great. Let's go ahead and click continue. All right, so let's look through this. This doc is concepts. So let's learn a little bit about these concepts. The first is the age-old debate of inline C# code versus partial classes. All right, what is this debate? What am I talking about? Well, let's go back to counter. Let's go back to our counter component, and we'll close this terminal tab so we have our space again. Okay, counter component, you'll notice that it's got markup for our UI, and it's also got C# code, and it's all in the same file. And that's super convenient because I don't have to like hop back and forth between other files. The code for the UI is right here. Now, if you're familiar with like ASP.NET Web Forms or other frameworks, a common pattern is to move that C# code into what's typically called a code behind file, so that doesn't live in the markup. And in fact, there have been very, passionate statements made in the past that thou shalt not put this code inside the markup file. Like they shall not mix. They are not meant to be together. It's like Romeo and Juliet, right? Well, okay, so let's think about this code for a second. This code that's living in this file is UI code. It's part of the logic of this UI component. The markup and the code is going to get compiled into a single .NET class. So you should think about that class like you would any other class, like it has a single purpose in life. All the code related to that purpose should live in that class. Any code not related to that purpose should not live in that class. Well, since this component is all about its UI, then having the UI code live in that class makes a lot of sense. Like sure, you should put that code there. Code that maybe doesn't make sense here would be like your business logic, like all your stuff for with your business rules, validation rules, and so forth. That shouldn't go in here. You should, inject services or use other types to encapsulate your business logic so it's decoupled from the UI. But any code related to the UI should be fine to go here. But no matter how many times we say that, there's always people that say, no, I want this code in a separate file. It needs to be in a code behind file, which is fine. You can do that. I'm going to show you the pattern real quick for how you set that up. So I'm going to add another file to my pages directory. This is not in the steps, but I'll just show you how to do it. So we're going to call this counter.razor.cs. Okay, that's the naming convention. If you're in Visual Studio, usually this will like nicely nest underneath the counter.razor file. It's kind of like the code behind file. Okay, and let's see if I can do this from scratch. Now this is a C# file, and what we want, first of all, we want the right namespace. So let's see, we want, oh man, I'm just gonna grab some stuff so that I can do this without messing up too much. I'm gonna grab a bunch of namespaces, and we want CI calc-pages is the namespace we want for this type. And I'm gonna name this class, it's gonna be a partial class. I'm gonna name it the same as my component. I'm gonna name it counter. That's the name of the class that will be generated from my counter.razor file. And it needs to derive from component base. Okay? Now this is a partial class that looks like I'm missing a namespace. What am I missing? I'm missing components probably. I think it's this one. Oh, I should just be able to do like a control dot. Yeah, okay, perfect. All right, so now we've got our counter component partial class. And if we want to, we can just go back to the Razor file. We should be able to just copy all of this code into that file and put it in this class like so. And this should operate exactly the same way. Like this is basically the same thing. We've just moved all that code that was in that @code block and put it into a partial class separate code file. So that's the pattern for doing partial classes. If I did this right, it should just work. Let's see if am I still building correctly? Let's make sure I don't see any errors. So that looks promising. Is my counter still functioning properly? Yes, it is. Okay, great. Well, actually, I need to refresh. Let's make sure that the refresh version also functions, and it does. Okay, so that's how you do the partial class version of your code. If you like that pattern better, it's fine, absolutely. We actually plan to add tooling gestures to refactor components in that way. It's a perfectly fine way to develop your apps. I like doing it in line, so feel free to pick the way that makes you happy. Okay, now we're going to talk about those Razor directives a little bit more. Razor directives are directives in your .razor files that affect how those components are going to be compiled. We've already seen two Razor directives. We've seen the @code directive, that's this one right here. That's just a directive that says, I'd like to put a block of code here that gets added to my class, like members, functions, members, methods, properties, just dump those into the class. If you want to really see that in action, you can dig around in your OBJ folder. Like go look under debug, Razor, pages. Here's the counter.razor.g.cs file. This hideous piece of C# code that you should never have to look at. But if you want to see what's really happening, this piece of code is what's generated from the .razor file. And you can see it's got a whole bunch of pragma stuff, but you can kind of see the code. Like there's the using statements, more using statements. There's our actual partial counter class that gets combined with the code behind file. Here's the route for the counter. It's just actually added as a route attribute on the generated class. That's what that @page Razor directive does. And then we've got this crazy looking code for capturing all the structure of the markup that we wrote. That beautiful markup we wrote in the .razor file is now turned into this crazy looking C# code. And then normally, because I factored this one to actually have the code now in a separate file, but if I had left the @code in there, then all of the code that I had in the @code block would be right down here below in this file. That's where we get generated. We could see that in fetch data. This is another component that generates that table. Like here, you can see all of the on initialized. This is the weather forecast array. This is all code in the fetch data component. Let me go open that guy up. I'm going to get out of here and back to the Pages Directive. So here's the fetch data component. We didn't look at this one in a lot of detail, but it's basically just a table that's using a C# for each loop to generate all those weather forecast rows in the table. So remember this table is being generated by a normal C# for each loop inside our Razor file. But it's also got an at code block with a whole bunch of code for running some logic when the component is initialized. It's making an HTTP request to the server. All this code is being captured in, let me go back now to fetch data at the bottom of this file. Okay, so that's, we looked under the hood there. If that scared you, don't worry, you don't have to look under the hood. That's just showing you a little bit about what's happening under the covers. Okay, so at code, just add some code to the generated class. We saw what at page does. That sets up a route for a component if you want your component to be routable. And it's basically just adding a route attribute to the generated class. Okay, the last Razor directive we want to look at is at bind. At bind is what we use for data binding, data from our UI to state in our component. Okay, let's take a look. Let me show you a little bit what data binding looks like real quick so you can understand what this is doing. So I'm going to go to the index page of my app, and I'm just going to add an input right here. So a normal text input, HTML input, okay? And I'm going to add an at code block. So I'm going to add some code to my component, and I'm going to define a string that's going to be text, some text, right? And what I want is I want whatever the user types in this input to be bound to this text field, this text variable. And then whatever's in this text variable to also be the value of the input. I want it to have that two-way bind, okay? So we could do that. Like we could say, we could do this manually. Like we could say, well, the value, this is just the normal HTML attribute for setting the value of an input. I want the value to be, I'm going to switch to C# by using that @ sign. I want it to be the value of that text variable. You notice I get nice IntelliSense in Visual Studio Code, okay? And then also, when this input changes, so when onChange happens, this is the onChange event, and I'm putting at before it to make this a Razor directive, a directive attribute actually. There's all my build errors showing up because I haven't finished typing all this stuff yet. When this thing changes, I want to set the value of that text field. So I'm going to put a little lambda, a little delegate right in here. You could also define the method in the code block and reference it by name using method group syntax, but I'm just going to put it in line. So this is C# code. So it has an event arg for the onChange event that I'm just going to call E. And I'm going to put a lambda symbol in here. And I'm going to take that text variable and set it to E.value. Value is the property on the event arg that I'm getting on the onChange event with the value of whatever the user typed. Okay, and it actually needs to be a string. By default, value is an object, so I'm just going to toString it. Okay, and so now if we, okay, to show that that's really working, let's also put like a p tag in here. And then I'm just going to render the value of that text field using, again, that @ symbol to say, please render the value of this C# code right here. All right, let's go back to our application. That should, let me refresh. Okay, now we've got our input. And as I type, hello, and then to trigger the onChange event, I have to, tab out, and boop, there. You can see that it actually bound the value and rendered the updated value. If I wanted this to instead to bind on every single time I type, then I need to use a different event. Like instead of onChange, I would say on input, then please set the value of the text variable every single time I hit the keystroke. Okay, so let's go back here. And now I'm going to start typing refresh. What am I doing wrong? Am I doing it wrong? And on input, is it not building? Let's make sure it's building. Looks like it built. Okay, okay, there it's going. Refresh. All right, A, B, C, D, C. Okay, it's as I type, it's now on input is firing. It's binding to the text variable. So that's how you can set up a two-way bind manually, like using event handlers, which is what we did here, and using just normal Razor syntax. But there's an easier way. Instead of doing all that, you can just say, let me delete all this. I just want to @bind to the value of this input to text. And I can complete that using Visual Studio Code. Okay, that does exactly the same thing as what we saw before. By default, it will use the onChange event. That's the default event. So if we go back to this now, it should be no longer updating with every keystroke. You know, I type a bunch of things and tab out, and then it updates. If I want to change the event, there is a syntax for doing that. I can say @bind:\event, and here I can specify the event name I want to use. Like I would like to use onInput. Okay, and now if I go back and wait for that to rebuild and refresh. Start time. Well, wait for it to rebuild, refresh, and start typing. Now it's using the onInput event. So that's what @bind does. Is it sets up a two-way bind. Oh man. Okay, so we're getting close to the end. We gotta finish up our app. Okay, so now let's add some logic to make our compound interest calculator work. Okay, so we're gonna add an @code block to our component, and we're going to add a whole bunch of state, like a bunch of fields and properties into our component. I'm just going to go ahead and copy this. We're going to give some state to our compound interest.razor component. Okay, so we're using @code and adding just a whole bunch of members to the generated class. That's pretty easy. All right, we also want a method that's going to calculate the compound interest. If you know math, then I'm sure this makes sense to you. I personally am just going to copy it. And again, I'm going to put it in this @code block. Just put it at the bottom. It's just a method, and fix your formatting. There you go. So now we have a method on our class as well. We're going to use this as our event handler. Instead of having like an inline lambda, we'll have an actual method like we had in the counter component. Okay, and then all we need to do is add some inputs in our table for specifying the current principal, the number of years, and the interest rate that are going to be bound to the properties that we set up above. Like we have the principal property, we've got the years property, and we've got the interest rate property as well. Okay, so we're just going to set up those binds. You could manually type these. I'm just going to copy the whole table and update the entire table. Okay, so now we've got inputs that are bound to the state of our component. And now we just need to have a gesture that will actually calculate the updated interest rate. And so let's go ahead and set up an onClick handler in our button. So let's go to our button. So the event we want is onClick. But I do to say I want to use C# @onClick. You get IntelliSense to help you find it. And then here, instead of putting like a lambda or a delegate, I'm just going to type the name of the method. You can hit Control Space to complete the method you want. And that's it. That was it. OK, that should be it. Now it says to build and run the app. We've already got the app building and running because we're using .NET Watch, which is fun. Let's go and refresh the browser so that we pull down the latest code. Maybe we do it one more time just to make sure we got the latest code. And there we got some inputs. And then we can click calculate. And that, I suppose, is the correct amount. If we up the interest rate to make it really expensive, then we should have a lot more money. Yeah, OK. So there, you just built a simple Blazor WebAssembly app with data binding, event handling, running on WebAssembly, all within the browser. In summary, that's what Blazor does, is it enables full stack .NET web development. You don't have to write any JavaScript. You can write rich interactive UI just using your C# and .NET skills. Now, this is just the beginning. Like this is just a simple, very simple Blazor application. Where do you go next from here? Well, I recommend going, of course, to the Blazor.net homepage. So just type Blazor.net, and that'll bring you to this page. And you can click on the documentation link. We've got all sorts of docs in here that you can learn all about how to build Blazor WebAssembly apps, all the features of the component model that we just didn't have time to talk about today. If you want more tutorial style instruction, there is a doc in the Blazor docs, this build a to-do list doc that will walk you through building like a to-do list app using Blazor WebAssembly. So definitely check that out. Or if you want like to know everything there is to know about Blazor, check out the Blazor workshop at aka.ms/Blazor workshop. And this will walk you through creating a whole pizza store app with British pizza, all in Blazor. All right, make sure I'm on the right slide. That is what we've got for you today. Let me say thank you To everyone who joined this call today, be sure to check out the Blazor.net is actually where I would point you to, but that link will work as well. Please share your feedback on this session, and I hope you enjoy the rest of Build. Also, this is just the first Learn session in the Rock, Paper, Scissors, Lizard, Spock collection. Make sure you get your swag for completing these sessions. There's also digital swag available at the link provided. And I think that's what we got time for. I hope you enjoy Build. Thank you for joining.